When we look up at the vast reaches of the solar system and to all our neighboring planets, there are notable differences between each of them. However, amongst all these differences, there is one aspect that seems to stand out more than anything else. Amid the presence of life as we know it, or the elemental composition and climate conditions of these planets, perhaps the most fascinating aspect is the fact that Jupiter, Saturn, Neptune, and Uranus are the only planets with rings. But this wasn't always the case. In fact, it may surprise you to hear that Earth looked more like Saturn's twin at one point in time. So, what was Earth's ring like, and why did it disappear? What secrets is our moon hiding about the Earth's past? And what would life be like if Earth still had a ring today? In order to truly understand Earth's past ring, we must first take a trip back in time. In 1734, Emanuel Swedenborg first proposed parts of the nebula hypothesis, which was developed further by Immanuel Kant in 1755 and published in his Universal Natural History and Theory of the Heavens. In this theory, gaseous clouds, known as nebulae, slowly rotate and gradually collapse, flattening due to gravity as they form stars, and then planets. According to this theory, the first celestial bodies that appeared from these clouds were not yet fully formed planets. Instead, they were protoplanetary disks, and then protoplanets, colliding and reforming, circling around each other as they settled into what is the solar system we know today. Around 80 million years after its formation, our planet, Earth, was on a collision course with a proposed Mars-sized body named Theia. In an angular incursion, Theia smashed into the Earth, and upon impact, the smaller body of Theia was completely obliterated, ripping off the outer layers of the Earth and leaving it a molten ball. This massive explosion, described first as a theory by Sir William Thomson, caused vaporized rock to engulf our planet in a thick atmosphere which over time condensed into a young molten moon, the moon we know today. According to Sarah T. Stewart, geochemists that have been measuring lunar samples and Earth samples found that the chemical signatures of the Earth and its one satellite are incredibly similar. The elemental isotopes are nearly identical for many elements. And adding to that, volatile elements have been vaporized away from the moon, which suggests that the two bodies share a common and cataclysmic origin. This is proof that the giant impact hypothesis might be close to truth. However, there's more to this theory than meets the eye, as you'll see. In order for a planet to have rings, they'd need to be located within the Roche limit, a term named for the French mathematician Édouard Roche in 1848. According to him, the gravitational pull an astronomical body exerts is unequal, stronger on the side closest to it and weaker on the side facing away. If any object, like a moon or its debris, crossed into the Roche limit and didn't have any gravitation to keep it together, the unequal attraction would tear them apart and probably form a ring around the stronger body. Too far out and they'd be scattered into space. Too close and they burn as they enter the atmosphere. Let's take a quick look at Saturn's rings and their characteristics. According to NASA, the rings could have evolved from debris of a collision between two icy moons a few 100 million years ago. The rings are not more than 400 million years old, which means they are much younger than the planet itself, as Saturn is around 4.5 billion years old. There is one big difference between the rings of Saturn and the one Earth had. Saturn lies farther away from the Sun, so its rings are formed from rocks, dust, and ice. Our ring would most likely have only been rock debris. Going back to the giant impact theory, there was a period of time, lasting a few hundred years, or potentially a few million years after Theia collided with Earth, where the debris left over from the collision was likely trapped within the Roche limit before managing to be gravitationally attracted to the newly formed Earth or Moon. This is also why Saturn is expected to completely lose its rings in around 300 million years. What keeps rings where they are is a meticulous balance of gravitational forces between the planet and its shepherd moons. Since our moon is close to the Earth and exerts enough force to move the ocean tides, if Earth managed to have rings today, Our moon probably would cause the rings to fall apart eventually. But what would life actually be like if Earth still had a ring today? If it was still intact, the view of the ring from Earth would also be different depending on where you live on the planet. It's assumed that it would form parallel to Earth's equator, where you would see it as a bright line cutting across the sky, dividing it in two and stretching as far as the eye could see. Such a vision would be common in many cities in the northern half of Brazil, Central Africa, and Indonesia. As you move farther away from the equator into higher latitudes, you would see the ring change in appearance. It would become wider, and some of its higher points would come close to touching the horizon. As the moon does, the ring would reflect the light of the sun to Earth at night and glow similar to Saturn. Depending on the size and thickness, it could reflect enough sunlight back to Earth and never allow it to plunge into full darkness. This would drastically change our way of understanding nights as they currently are. This ring could also pose a problem to our satellite infrastructure. Launching objects into space would need to take into account the existence of a large structure surrounding the planet when making calculations on how to navigate into the proper position. Much of the same would happen to space missions, which could be impacted by the ring as they leave or enter the atmosphere. But you can imagine the view you would have from a spacecraft as it crossed beside the ring, or how close to it you could be from the International Space Station. A ring around the Earth could also impact our climate and the way vegetation grows on the planet. Currently, plants do not photosynthesize during the night, even on the brightest moon. But if the ring around the Earth managed to reflect enough light for it to happen, this could change our understanding of biology. Plants could grow faster, and evolution over millions of years might have gone a completely different route. The reflected sunlight in parts of the globe could also contribute to warming of other places, making weather patterns change completely from what we see today. However, if the sheet of debris in the ring was too thick, it could act as a shield against sunlight, preventing rays from reaching the surface and leading to even lower temperatures on higher latitudes. This could have a real impact on our ability to grow food, as well as ocean currents and humidity distribution across the globe. The giant impact hypothesis is the most widely accepted theory for the moon nowadays, yet many scientists have hypothesized different creation concepts for the moon, which don't even include the existence of a ring. The truth is, the planet is not surrounded by a ring anymore, and if it had been in the past, it was long ago and short-lived. Still, we can lay in wonder at what our life would be like and how different the Earth might look if we could stare at the sky and feel embraced by a ring of light even brighter than the largest moon.